Hey guys, I wanted to go over a couple of the 2.1 and 2.2. There was a couple of questions on 2.1 with the coterminal angles that I've noticed a lot of you guys were struggling with. And then also in 2.2, the hamster wheel question with the angular velocity and linear velocity. I want to go over that one as well. I'm going to turn the screen around, whiteboard, and kind of just show you guys, work with you on a couple of these questions that I noticed that you were having issues with. All right, so in 2.1, the video, and obviously, the video questions are very similar to the homework questions. So if you can do the video questions, you should be able to do the homework and vice versa. So I think it was question 8, and the order of these may be a little bit different. And it asked you to find the coterminal angles of these. And it wanted your coterminal angle to be between 0 and 2 pi. And so this was the reason why some of you guys missed this question. Your answers of your angles were not between 0 and 2 pi. So one of the first ones that I looked at was 13 pi over 5, right? So, I think some of you guys, and you did these same questions with degrees. And I think some of you guys think they're more difficult because they are in radian measures. And so what I would say to you is if you don't like working with radian measures, then change it to a degree. And then what you can do at the end is change it back to a radian and you're done. So that's what I'm going to do with you guys. Let's go back over how do I change this to a degree? Well, anytime that you want to change a radian to a degree, you have to get rid of the radian measure, and we do 180 over pi. And this works every single time. There were numerous questions on the quiz going over this, and I think most of you guys got that correct. So we do 13 times 180, which is 2,340, and we end up dividing that by 5, and that's going to be 468. Okay. So obviously here, we are doing a full 360, and then we need to see, okay, how many more do I go? So what we would do is subtract 360 from this, and we would have 108, okay? We would have 108 there. And so that's not going to be a full, it's not going to be full to 180, okay? And you can think 108 minus 90, it's going to give you 18 degrees here. But anyway, so 108 technically is between 0 and 2 pi. This is not the answer they wanted, right? So if you think 108, let's see. We want to change this to a radian measure. So we will multiply it by pi over 180. And so 108 divided by 180, going to be 0.6, which is actually 3 over 5 pi. Okay, so this is the answer that you should input into the My Open Math. All right. The next one is negative 10 pi over 3. The program talks about adding 2 pi or taking away 2 pi. My thing is change it to a degree and then draw it on the unit circle, and then you can kind of see what you have to do. So again, I'm going to change this to a degree. So 180 over pi, your pi's cancel, negative 10 times 180, and then divide it by 3. And that's going to give you negative 600 degrees. So remember, a negative angle goes this direction. So I'm going to go a full 360. And so what I'm going to need to do is I'm going to say, okay, how many do I have left over? Well, 600 minus 360 is going to give you 240. So I keep going. This is negative 90. This is negative 180. All right, so how many from 240 to 180? How many do I have left over? 240 minus 180 is going to be 60 degrees. So right here, 60 degrees. So I'm going to here. So that makes 30 left over here. Okay. So again, we can't let this be a negative angle, right? We can't let this be a negative 240 because that's what it was, okay? So if you put negative 240 as your answer, it's going to be wrong. But what I can do is I can look at this angle from the positive side because that's also the same coterminal angle. And so I have 90 plus my 30 is going to be 120 degrees. And what I can do is I can change that to a radian measure. And 120 over 180 is going to be 2 over 3 pi. Okay, so I think some of you guys are just looking at this with the radian measure and you're getting confused because you're not as confident with radians. And like I said, what I would just do is change it to a degree, draw the angle, and then change it back to a radian measure if that helps you. All right, let's do one more. The 77 pi over 2. There was 4 of these, but I'm just going to do one more. So again, I'm going to change this. All right, so 77, obviously this is going to be a huge angle measure. And it's going to give us 6,930. Okay, so obviously we're going to be doing lots of circles. So what I would suggest do is, okay, divide this by 360 and see how many loops are we doing. So 6,009 divided by 360. It's going to go in about 19 times. There's going to be some left over. It's like 0.25. Okay, so let's see how many degrees we have left over. So what you would do is you would do 360 times 19. And that's going to give us 6,840. And we want to say, okay, how many do I have left over? How many degrees do I have left over from here? All right, so 6,930 minus 6,840. And we have exactly 90 degrees left, which meets our criteria, which is here, right? And of being between 0 and 2 pi. And I know 90 degrees is the same thing as pi over 2. But again, if you don't know that, multiply it by pi over 180. 90 over 180 reduces to 1/2, right? So that's going to be pi over 2. Okay? So that was the ones on 2.1 that most of you guys missed. In 2.2, I wanted to go over the hamster running. Some of the questions I got rid of with the angular velocity because technically it used something a little bit different. And I'm not really going to give you guys a question like that on your test. It was a little bit more in depth than I wanted it to be. So that's why I got rid of a couple of questions. For future classes, I'll make sure just to not have those up there. But question 4 was one it's a pretty straightforward question, but I wanted to go over it. So it said a hamster is running in a wheel. So it's running in a wheel, with a radius of 11 centimeters, and it spins the wheel 1 revolution in 18 seconds. Okay, and it asks for the angular velocity, and then it also asks for the linear velocity. Now, if you read your book like you were supposed to and you watched the videos like you were supposed to, you would know that the book represents the angular velocity with the Greek alpha letter like this, and it's theta over time. Remember, theta is your angle measurement. So let's pick out what we have here. We have a radius, which is 11 centimeters. We have theta, which is 1 revolution. 1 revolution means 1 circle, which means 2 pi, right? And we have time here is 18 seconds. So if I fill in my formula here, 2 pi is my theta, time is 18 seconds, and then we just reduce this. What is this going to be equal to? It's going to be equal to pi over 9, okay? And this would be radians per second, all right? And then linear velocity formula is just your radius times your angular velocity. So I already have my angular velocity as pi over 9, and I know my radius is 11 times that, right? So your answer would just be 11 over 9 pi, okay? And technically this would be centimeters per second still, but anyway. So there were several questions like that. There were questions about your arc length, which there's formulas for. And always make sure you take a look at the key notes that I give you guys, because I kind of go over the key formulas that you need and kind of have that handy when you guys are doing your quizzes, your homeworks, and your videos. And as always, email me if you have questions on these before Thursday. Thursday is the day that it's due. You guys should not be starting your assignments on Thursday, okay? And if you ask me a question about it, I'm probably not going to answer if it's on a Thursday. Now, if you start your assignments a week earlier, let's say you start it on Monday and you ask me a question, I will be happy to help you and work on that question with you, and maybe make a quick video or, a little problem, work out the problem for you. But you guys should be working on these all along, all week long, and not waiting to the last minute to do your assignments. All right. That is it. Thank you, guys.